Hi everyone and welcome back to R&M LAB GH. Today, I need to repair my drill's battery pack. Unfortunately, one of them has stopped working, which means the internal cells are likely dead. A while ago, I salvaged a battery pack from an old laptop and recovered the internal cells. Now, let's see if we can use them to fix the drill battery so I can have two working units again, which is essential for my work. Safety is extremely important when handling these types of batteries. You must be very careful. Lithium batteries can be dangerous, especially when you are separating or soldering them. Another crucial step is checking the polarity. As you will see in the video, I mark the positive and negative terminals clearly to ensure the new cells are installed correctly and safely. Enjoy the video. There is another crucial detail that must not be overlooked: the temperature probe. This sensor is connected between the circuit board and the battery cells. You must be very careful to remove it without damage, as the wires are very short and it's usually secured with a special silicone. With patience and care, it can be salvaged easily. This probe is vital for three main reasons. Charging monitor: it protects the system from overheating during the charging cycle. Usage protection: when the drill is under a heavy load, the batteries heat up. The probe detects this and cuts the power to prevent damage. Safety and longevity: it is the key component that prevents battery failure and ensures they last over time. Always make sure to put it back in the right place. As you can see, I check the cells using a multimeter. When they measure around 3 volts, they are still good. If they drop below 1.5 volts, they are depleted. In this pack, 3 out of 5 batteries are dead, while 2 are still in good condition. They aren't new, but definitely still usable. However, I am replacing all 5 of them. It is essential to have identical cells to ensure maximum efficiency and balance for the drill. The working batteries I've salvaged won't go to waste. I'll use them for other projects, such as powering Arduino circuits. In the lab, smart recycling is key. As you may have noticed, the workspace setup has changed. This video was filmed in 2 stages for 2 specific reasons. First, and most importantly, the equipment. The soldering iron I was originally using was too small and underpowered for this task. That model is great for electronics repairs on PCBs and SMD components, but for heavy-duty jobs like this, you need more heat. That's why I bought a new one. If you want to see this short about the new soldering iron and how I prep the tip, you'll find the link in the description. The second reason is that I've completely renovated the workspace. I've reorganized my tools to produce higher quality content. You'll also notice a new workbench cover. It's lighter now, which provides much better contrast for the videos. If you want to see the video of the lab's restoration, I've left the link in the description. After this quick update, let's get back to the repair. I want to share a vital tip for achieving professional-grade solder joints on electronic components, cables or batteries. The golden rule is that the quality of your solder depends directly on how clean the surfaces are. If the metal is oxidized or dirty, the solder will never bond correctly. That's why I always start by thoroughly cleaning the contacts with isopropyl alcohol. For tougher spots, I use a fiberglass pen. This tool is fantastic because it allows you to scrape away oxidation without excessively damaging the traces or terminals. Another essential item is flux. It is crucial for both soldering and desoldering, as it helps the heat distribute evenly and prevents oxidation during the process. For better precision, I transfer it into simple pharmacy syringes. I keep a very small one ready for precise circuit work and a standard size one for larger jobs, like these batteries. It's a cheap and practical method that gives you total control over the amount of product you apply. we've reached the end of today's project. We achieved exactly what we set out to do. The battery pack is fully rebuilt and working perfectly. Now all that's left is to put it on the charger to reach full capacity and test it out on the job. It took a bit of work and patience, but it was worth it. The satisfaction is double because, thanks to salvaging those cells, we spent practically nothing. Most importantly, I finally have both drill batteries working again. I'm really happy with how this turned out. Thank you so much for watching. If you enjoyed the video or found it helpful, please remember to subscribe to the channel, leave a like, and drop a comment to let me know your thoughts. Don't forget to hit the notification bell so you don't miss any upcoming restorations or projects here at R&M LAB GH. Thanks for the support, and I'll see you in the next video. Bye!